Have you ever found yourself just, staring at a problem? Could be a complex new project at work, maybe a learning challenge that feels really stubborn, or just trying to manage a flood of emotions. And you're thinking, how do I even begin to tackle this?
Yeah, and our go-to response almost always is more thinking, more talking. We lean into these abstract theories.
We try to intellectualize our way through it.
Precisely. We're sort of wired to lean into those cognitive, those verbal methods.
Mm.
But here's where the real shift happens, based on some really eye-opening insights from neuroscience and motor learning. The human brain isn't just a thinking organ. It's fundamentally, profoundly designed to move.
Okay, this is where it gets really interesting, I think. So the core idea for this deep dive is applying something called motor science to those everyday challenges. Imagine your brain literally rewiring itself for better memory, sharper focus, maybe stronger emotional control, just by changing how you interact with the world physically. So our mission today is really to explore this transformative approach. How can the right kind of movement convert challenges into tangible, actionable opportunities?
And what's truly revolutionary here is that motor science goes far beyond just, basic biology. It's an interdisciplinary study. It looks at how our body moves, how the nervous system regulates that movement,
Yeah.
covering everything from how we learn movements, the mechanics of our actions, and that really intricate dance between brain, body, and senses.
So it's not just about what our muscles are doing then, it's more like a practical, actionable model for learning anything, really. Forming habits, modifying behavior, even managing our emotions.
Exactly. The critical shift, the big idea, is that movement becomes a medium for learning, for healing, for performing better.
Okay, a medium. So like motor actions are what? Coded instructions?
Kind of, yeah. Think of them as coded instructions that literally help structure the mind. They activate specific neural circuits, and they significantly enhance how we form long-term memories. Your movements aren't just physical outputs, they're actively writing instructions for your brain.
Wow, okay. And this isn't just a nice idea, right? There's actual neurology behind this.
Oh, absolutely. There's a strong neurological basis.
Hmm.
When you engage in motor actions, you light up key brain structures. Think basal ganglia, crucial for habits, learning routines.
Uh-huh.
The cerebellum, which is the brain's incredible coordinator for movement, precision, even some cognitive stuff.
Hmm.
The motor cortex, obviously, is heavily involved.
Right.
Plus, the prefrontal cortex, that's your executive control center, for planning, decision-making, self-control, that also jumped into action.
So what's the big takeaway here? These activations, they don't just happen in isolation, do they?
Not at all. They actively strengthen the neural pathways,
Right.
the ones directly related to memory, attention, decision-making, and the result: measurably improved cognitive and behavioral performance. It's like your brain is literally rewiring itself through movement, making you sharper, more effective.
Okay, let's see this in action then. How does motor science actually work across different parts of life? Maybe start with academic challenges.
Good place to start. Common issues there like poor attention, maybe lack of motivation, learning disabilities, even just classroom anxiety. They're often tackled with those same passive methods we mentioned, lectures, repetition.
Right, the sit and get model. But motor science completely flips that script, doesn't it?
It really does. Instead of just passive reception, students engage physically, actively.
So what does that look like? Give me some examples.
Sure. Think about task-specific learning, where you learn by doing the actual thing,
Oh.
or book-to-brain, brain page making.
Brain page making, what's that?
It basically means physically sketching, diagramming, or sort of building out your knowledge onto a physical page, making it tangible. Then there's project-based execution, which is very hands-on learning. Cycle-side rehearsals, those are structured, repeated physical practices of a concept. And brain page modules, where entire lessons are actually constructed through physical actions.
It's all about doing then, not just listening or reading.
Precisely. And this leads to some really profound benefits. First, much better memory encoding. Physical engagement dramatically improves those connections in the brain's memory circuits, the hippocampal cortical ones, especially for long-term stuff.
Okay, better memory. What else?
You also see significantly more focused attention. Because these motor tasks, they activate those brain regions, the basal ganglia, the cerebellum, that are key for regulating attention and precision.
Interesting. And faster learning cycles too, you mentioned.
Yeah, exactly. The repetition involved in motor actions strengthens neural plasticity. That's the brain's ability to adapt and change, so mastery becomes quicker, more ingrained.
And you also said it helps with anxiety.
It does. It can significantly reduce classroom anxiety and cognitive overload. It provides a kind of calming, structured alternative to just trying to mentally absorb tons of information.
That feels like a game changer, especially for learners who struggle with traditional
It
methods.
really can be. And this approach is also incredibly effective for behavioral and emotional challenges too.
Okay, how so? Like issues like attention deficits, maybe impulsivity or emotional dysregulation?
Exactly those. They often benefit far more from movement-based therapy and task modulation than, say, traditional verbal counseling alone. Or at least it's a very powerful addition.
So how does that look in practice? Can you give us some concrete examples there?
Absolutely. Think about repetitive motor tasks. Simple things like reading aloud, specific writing exercises, sketching, using tools. These actively engage the prefrontal cortex.
The planning part of the brain.
Right, which leads to better executive functions, planning, decision-making. Then you have fine motor activities like handcrafting, playing musical instruments.
Mm.
These stimulate the sensorimotor cortex. That helps develop things like patience, focus, and emotional regulation.
Okay.
And importantly, team-based motor challenges, things that require physical coordination and problem-solving together. They promote empathy, collaboration, even conflict resolution skills.
Wow, so you're essentially transforming behavioral issues into active learning experiences. And emotional distress can become an opportunity for what? Mindfulness and self-discipline through action.
That's a great way to put it. But this raises an important question, right?
Right.
How does this apply beyond the classroom or therapy? What about, say, professional settings, personal growth?
Yeah, good point. Workplace challenges, lack of creativity, low productivity, communication gaps.
Yeah.
Are those addressable too?
Definitely. Motor science offers incredibly dynamic solutions here. Think motor-driven training sessions, interactive problem-solving tasks where people are actually moving and manipulating things, role-based simulations, things that involve movement, decision-making, tactile engagement, not just sitting around a conference table talking.
And the why behind this is intriguing too. You said movement stimulates both brain hemispheres.
That's right. It seems to promote creative thinking, often associated with the right brain, and analytical problem-solving from the left brain.
Yeah.
Plus, you get that integrated practical decision-making coordinated by the prefrontal cortex.
So you're engaging the whole mental toolkit, basically.
Exactly. By incorporating motor science into leadership training, team building, organizations can build more resilient, adaptable, action-oriented teams. Those professional challenges, they actually become gateways to improve performance, innovation, and really holistic team development. It builds a culture of doing.
Okay, and if we connect this to the bigger picture, there's this concept you mentioned before, learnography, described as the science of learning from the brain's perspective.
Yes.
And what's key, you're saying, is that learnography actually integrates motor science as a core component, making it a truly holistic approach.
Indeed, the synergy is very clear there.
Hmm.
In learnography, you have the brainpage module.
Mhm.
That's a structured method of physically constructing knowledge, drawing, writing, connecting ideas on paper. It's built entirely through motor action.
Right, the thing you mentioned earlier.
Then there's the miniature school system. It's a concept within learnography that replaces passive classrooms with active, team-based learning spaces. Movement and collaboration are central.
Okay.
And finally, the task formator. It's a specific guiding tool that transfers knowledge precisely through step-by-step motor execution, following a set physical process to learn something.
So this combination, learnography plus motor science, ensures that you, the learner, don't just passively acquire knowledge. You actively construct it, physically, emotionally, intellectually. It makes every challenge a more meaningful and probably more lasting experience.
You're building understanding with your whole self.
Yeah.
And the findings, the evidence supporting this, are really robust. We see measurable transformations through movement.
Okay, let's summarize those key findings then. What does the research really show?
Well, first, consistent motor engagement activates those essential neural structures we talked about. Basal ganglia, cerebellum, prefrontal cortex, leading to significant improvements in memory, task planning, attention, emotional regulation. That's number one.
Okay, brain activation. Got it.
Second, physical task execution. Actually doing something dramatically enhances long-term knowledge retention compared to just passive methods like listening or reading. Active motor encoding is vital.
Right, doing beats just hearing. Makes sense. What's third?
Third, action-based learning environments. They drastically reduce classroom anxiety and cognitive overload. They create a calmer, more focused, and ultimately more effective learning experience.
Less stress, more focus. Okay.
Fourth, consistent motor activities like those structured brain page rehearsals or fine motor exercises. They effectively modulate behavioral and emotional challenges, They help individuals develop self-regulation over time.
So practical skills for managing behavior and emotion. Good. Fifth.
Fifth, in collaborative setups, like those miniature schools, motor-based interactions demonstrably improve peer-to-peer learning, collaborative problem-solving, even leadership development. Physical participation boosts social-emotional skills.
Interesting. So moving together helps us work together better. And sixth.
And sixth, the principles of learnography really seem to amplify the benefits of motor science. They make knowledge acquisition faster, more organized, and deeply personalized. That synergy creates a powerful learning system.
A system capable of turning even abstract challenges into clear, structured, achievable tasks. And finally,
Across diverse case studies, this transformation from challenge to opportunity isn't just measurable, it's highly replicable. We see consistent results, which is really encouraging.
it really proves the profound power of integrating movement into how we learn and grow.
It absolutely does.
So to bring it all back to the core message then, challenges aren't really obstacles in the way we usually think of them.
No, they're more like potent opportunities, just waiting to be activated through your own actions.
And that's why we encourage you, whether you're an educator rethinking your classroom, maybe a parent guiding a child, a leader building a team, or simply a learner striving for mastery, to embrace this incredible power of motor science.
Yeah, maybe rethink education a bit. Empower students by doing. Train teachers, train parents in these hands-on tasks. Transform environments into active spaces for learning and growth.
It feels particularly relevant now, in an age that's increasingly dominated by, AI and digital distraction. Motor science kind of reminds us of the profound inherent intelligence of the moving human brain.
Well said. The answer to so many of our modern challenges, maybe it doesn't always lie in more talking, more testing, or more abstract theory.
Maybe it lies in movement, in action,
No.
in the motor science of knowledge transfer.
Move to learn. Learn to transform. Because action really is the beginning of change.
And motion is the gateway to mastery.